Hello and welcome everyone. In this day 36 learning, we are going to be looking at symbol tables and introduction and implementation of symbol tables. We have already completed searching and before that sorting techniques. Here we are going to be looking at symbol tables, right? So we have all come across a dictionary or maybe a real world website where we get to search for a website name such as google.com, and it redirects us to a Google page or Google search engine, right? So so that might be an example of a symbol table is nothing more than a uh, dictionary or dictionary in Python, or map, or objects in JavaScript, or hash tables, right? So all this means is there will be a key which is associated with a value of any type. It can be array, objects, or uh, lists, or anything, right? Strings, numbers, whatever it wants to be. Right? So there are multiple implementation of uh, hash tables or symbol tables. So few implementations that we are going to be looking at is going to be with array, either ordered or sorted or unordered. Unordered. And there is also another way with hash tables or objects or maps. And also lastly we can use BST, binary search trees also, right? So let's look at few implementation examples. And before even looking at implementation details, let's have a little uh, thought process. So for example, if a user searches for a web page called google.com, so there would be a DNS lookup which happens. So google.com, there would be a DNS server which would be like a hash table, domain name server or system. So this would be like a hash table where, let's say, google.com would be assigned with some IP like 101 dot 108.10.1 or something like this. And let's say we ask for youtube.com, it will have an address of the system. So this will be returned to google.com, and eventually this will be passed back to uh, the client monitor, right? So this is how DNS lookup works. Asks and retrieves 101.18. This would be the address of the server of google.com, which would return the web page, right? So yeah, uh, this is the whole idea of how search on internet works with the help of a DNS servers. So now let's think about the implementation with uh, a simple unordered array. So let's call this implementation with unordered array, or unsorted array. Like, let's say we have an array of objects, we can create an object like google.com. uh, Say google.com having an array of two values, which is index one will be the domain name and the domain address, like for example 2010, and let's say youtube.com. youtube.com having 113 and 1.105.67, something like this, right? So it can go on. So consider this as an unordered array where it has an array of items, and all of these are unsorted, and each array has two values. One is the uh, domain URL, and this is the server address, which DNS resolves into, right? So let's understand the implementation of such simple unordered array hash table, right? So we can have a simple class which takes in, and let's say something like let's call this as a bucket, and let it be an array, and let's say we would have functions or useful methods in this class, implementation class, to insert or put a value into an array, like key value. So this can be like insert, iterate through this array, and to length, and if there exists a value key at bucket of I and 0 exists, then update the value. Update value, like bucket of I of 1 is equals to value. So that's what we are going to do with put method. So we can also have a get method for a key, iterate through the array, and if uh, length of bucket, and if bucket of I of 0 is equals to key, then return bucket I of 1, else false, right? Say that there is no value, return false. So that would be get function. And similarly we can have delete, where we need to delete a key, like iterate I length to length of bucket to length of bucket, and if bucket of I at 0 is equals to key, uh, then bucket dot slice at I to 1 position. So else, if there is nothing, return false, indicating that key doesn't exist, right? So we can have many other functions like contains or size or even keys, so on, right? We can have so on. So this is one way. Let me quickly switch to the JSPin editor and let's quickly walk through this code. Okay, so here I have an array symbol table class, a simple entries array, and put method. If uh, there exists a key, then update the value, else push a new array into the entries array, and get a value. If there is a pair found, then return the value of it, else undefined. Delete goes the same way with splice function. Contains checks if there is a key with this get function, else returns false. Size returns the total length. Yeah, this is a simple implementation of unordered array hash table or symbol table, right? So here, as you see, we have added these set of uh, URL names or domain names, and these are the domain addresses for them. And we are using get method to retrieve, and contains check if has the value and its size, and delete a specific value and see if the value changes. So these are all basic operations, right? So yeah. Okay, so I will not switch to the drawing board. I will. We can directly look into the unordered or ordered symbol table implementation, which I have here. So in case of ordered symbol table, so we insert the keys in a sorted order, which would bring out optimization in the lookup time and time complexity. For example, we binary search the index and then insert the value. Like we select the appropriate index and then insert the value accordingly. Like for example, we have a key like uh, Amazon. So A starts at the zeroth index, or it should be at the first most position alphabetically. It takes a higher precedence. Similarly, GI takes a higher precedence than GO, where this I is uh, seen much earlier than the occurrence of O, right? So that way, the rank function helps us uh, give an index where we can place the value, right? Okay, so that's the whole idea. You can go through this code snippet. I will have it pasted in the GitHub link with the video description, and you can take a look at it. So we have a set of console logs to run them. So let's look at time and space complexities for both of them. So both of them have often put time complexity, and only difference here is login, because binary search takes login time complexity to get a value, right? So all others are the same, right? Okay, so I will add in the last piece, which is a BST implementation, and let's talk on that. Okay, let's look at the last one, which is uh, implementation of symbol table with binary search trees, or BST, right? As you know, BSTs are sorted trees where left values are always less than the root, and also less than the root is less than the right side portion of the tree. So we store this way. Like for example, here we see Google being a root node, and right side L being the left node being the local host being greater than Google, because L comes after G, and similarly GitHub is placed left of this Google, but at the same time right of this Amazon. But GitHub is of on the left side of google.com, even though it's not clearly identifiable, right? So there are few functions that are there here. So let's say insert, if it's the first node, increase the size and just return a new node. Else we recursively use this put function to add it to the right place in the left portion, else the right portion, right? So that's about it, and we update the node value. Okay, so these other functions are also easy to understand. You can go through these knowing the BST properties, and you can understand the implementation. The time complexity of BST implementation of symbol table is the most optimal one, where login, insertion, and deletion also are the most optimal. Space complexity is obviously n. Okay, so that's it for this video. Hope you found this video helpful. If there are any doubts or clarifying questions that you have, please post them in the comment section. I would be happy to look into comments and respond there. Please do like and subscribe to my channel. Thank you.